Good evening, everyone.
Good evening, everyone.
Good evening.
Good evening.
Good evening. I'm Shiva Shankari. The topic today we'll be dealing with is the advanced treatment techniques in wastewater treatment. So let's begin the class. So to introduce myself, I'm Shiva Shankari. I'm a PMRF scholar from IIT Madras. So I'm one of the TAs, one among the three people who is handling the doubt clarification session for this. So I'm a PMR of TA, like who is handling the doubt clarification session for this NPTEL course, wastewater treatment and recycling. So today, let's start the class. So the agenda for today's class would be basically first we will discuss on what are the things that the professor has like gone through like for maybe 5 to 10 minutes. Then I have some 10 problems which we can solve. Those are simple problems. There are only two problems that two each of 1 point only this time in the assignment. So I have taken same problem with different numbers for those two problems, as well as I have added few more additional problems since this week the problems given in the assignment are few. So I have like taken few more simple additional problems that can be like helpful for us to understand the subject and concept. Okay, so let me share my iPad screen. So today's session is in so this week the professor had like taught about the advanced treatment techniques that have been adapted in treatment of water treatment plants. Okay, conventionally they have used in so many places they have used ASP and trickling filter for the secondary treatment purpose. For the purpose of secondary treatment in wastewater plants. However, we have recent like emerging techniques such as SBR, which is nothing but the sequential batch reactor. Okay, so in sequential batch reactor, what will basically happen is the process instead of taking place in two different tanks. In conventional ASP, what happens? The first one is the aeration tank. This is the aeration tank, followed by the secondary sedimentation tank we have, right? So this is what is for conventional ASP. This is conventional. However, in case of sequential batch reactor (SBR), what is happening is have a single tank. Okay, so you have a single tank. In the same tank itself, all the process takes place. That is, it uh, it this acts as a batch. This acts as a batch process happening sequentially. Okay, so what happens is in this there are some five processes, four to five processes. So the processes continues in and all the processes together takes place in the SBR tank, that is in the batch reactor, and for completing all five processes at once in sequential manner, it is known as one cycle. Okay, for example, like the cycle, one cycle, one cycle in an SBR includes the following operations. Fill, react, settle, and idle. Okay, This is what is called as one cycle includes fill, react, settle, draw, and idle. All these processes takes place in the same batch reactor. Takes place in the same batch reactor. Just give me a minute. Just a minute. Okay. So the next type is SBBR. Okay. Which is nothing but the sequential batch bioreactor. In this, what happens is it is very similar to that of SBR. Okay, but then there is a small difference. The only difference between SBR and SBBR is that in SBR the microbes are just microbes are suspended. In SBBR, the microbes are attached to the carrier. Okay, so the carrier is nothing but the one that holds the microbes, uh, like in which the microbes are grown. Okay, it will be some sort of like plastic like carriers like this, and then the microbes will be grown in this, and it will be present inside the tank. Here the microbes will be present directly. Okay, so here there will be multiple carriers like this. So what are the desirable properties that you need for the carrier is that it should not be highly dense. If it is higher in density compared with water, what is going to happen? It is going to settle down, right? If it is very low in density, then it will always float on the top. We don't want both the things. We want to make sure it is utilized properly in the effective volume. So the density should be approximately um, lesser, less than water, approximately equal to water. Okay, so and it should be non-reactive, obviously. So if the carrier material is reactive, then it's gonna be becoming harmful for the bacteria. So they won't be able to like do the treatment properly. So that should not be present. And also, thing is, the microbes should be able to sit on the carrier surface. Okay, thing is the carrier surface should not be very smooth as well. So carrier surface should not be very smooth. So these are the desirable like characteristics for the carrier. Okay, so the next type is Yes, Kanu, tell me.
Yeah, for this case, the sludge or biomass should be settled or it cannot be settled.
Uh, 1 second, I'm not able to hear you. Yeah,
Yeah,
tell me.
in this case, in SBR or SBBR technology,
Yes.
whether the sludge produced in this tank or batch,
Sledge,
it,
sledge.
it will settle down or
Okay, I'm coming to that. Yeah, yeah, yeah. In SBR, it will settle. Okay. In MBBR, in SBBR, it won't. We have to keep. We have to like. What to tell? There may be one or two microbes escaping. Okay, but we won't take the carrier out in SBBR.
okay, then how will we flush out this sludge?
There will be very less sludge production actually.
Okay,
Okay, and if there is on that sledge also, we can use either membrane or a small settling tank to remove.
okay. So
Okay,
it will be transferred to another tank.
no, it can be done in the same tank itself. That's why it is sequential batch reactor. No, see here, the settling also takes place. The difference between SBBR and SBR is that only the carrier will be present over here, but
Yeah,
the
that,
set,
that I understand. But
yeah,
my question is that the what should we do with this biomass or this either
it
this
will get
biomass or the
settled.
slag,
It will get settled. It will get settled.
and it will be flushed out
Yeah, it will be scrapped out.
in both the case in SBR as well as in SBBR.
Yes.
Okay, ma'am. Okay.
Okay. Okay. So with this, SBBR is done, and then we have MBR, membrane bioreactor. This is very similar to ASP, except the fact in case of ASP we have a secondary sedimentation tank for removing the sludge or biomass, right? Sludge or biomass removal. In case of ASP, okay. But then in case of MBR, instead of putting a secondary clarifier, they have a membrane over here to remove the sludge or the biomass. For sludge removal, membranes such as microfiltration or UF, ultrafiltration or microfiltration, UF or MF. Okay, so this is MBR.
From beginning to end, plus, ma'am, from beginning to end, please, you can explain.
What?
From beginning to end, you can explain very short
I'm
manner.
not able to hear properly. 1 second. Yeah, tell me.
From beginning to end, you can explain in the short way summary.
What? Hello. Can you type it? Can you type it? I don't know what is the problem. Can you please type it? I'm not able to hear you clearly.
Ma'am, from beginning to end, please, you can explain the
You
short.
type in the message. See here. See my screen. Here there is a message, right? Type here. Because your voice is not at all clear. So, um,
Ma'am, now I can audible clear.
yeah. Now it is audible. Yeah, tell me.
Ma'am, since from beginning to end, you can explain in the short summary.
From the beginning to the ending.
Yeah, right.
In sense like like what do you want to like
Yeah, SBBR, ma'am, sequential batch bioreactor.
sequential batch bioreactor? Yes, it is similar to SBR, that is sequential batch reactor, but then we have a carriers made of plastics, and in the carriers our microbes will go and sit and the process will take place, which is very similar to SBR or normal treatment technique. Okay. Is it okay, Naidu? Okay. Thank you. Then we have MBBR, that is membrane bioreactor. In MBBR, no, MBBR, it is, one second, MBBR is
Membrane biofilm bioreactor, I think.
membrane?
Biofilm, I think.
Biofilm, yep. I forgot the word.
Ma'am, I think you are the stop our screen saver now.
What?
Yeah, ma'am, moving bed bioreactor.
Huh?
Moving bed bioreactor or membrane biofilm bioreactor?
Wait, one second, let me just check it. Like, I got confused. One second. Let me just check it.
Yeah, it is moving bed bioreactor.
That's what I was, yeah, that's what I was wondering. Yeah, moving
Yeah,
bed.
moving bed.
Okay, so this is very similar to um, this one. Okay, here also we have the carriers.
Ma'am, you did stop your screens. Please, can you check again?
I'm sharing the screen already. My iPad screen, right?
Yes, ma'am.
Um, it is already shared. Is it not visible?
Yeah, now it's good, right. Now it is going on.
I'm sharing it already, Naidu. I think you have to like check it. One second. Now is it visible? Now is it visible?
Yeah, it's visible, ma'am.
Okay, thank you. Okay, so here we have carriers that hold the microbes. And the treatment process takes place. Okay, like wait, I will show you something. See here. This is the carrier. This is how the carrier looks. Okay, in this there will be the microbe sitting. Okay, this is what I wanted to show. Okay, so now let's move to the problems.
Ma'am, can I ask a question?
Yeah, sure.
Yeah. In case of SBR
Yes.
and SBBR,
Okay.
so we can tell that SBBR is the advanced version of SBR. Can we
Yes.
tell? Yeah.
Yes. Obviously,
But
yes.
again, in case of MBR and MBBR, MBR is the advanced version of activated sludge process,
Yeah,
ASP.
exactly.
Again, MBBR is also advanced version of ASP.
Yes.
So
Yes.
can we tell that MBBR is the advanced version of MBR?
No, how can you tell? Because in MBR, you're using what to tell? You are using membrane. Here, you are not
Yeah.
using any membrane for separation, right? If you are using membrane for separation, then you can tell. See, it's all the logics. In the thing which I showed, no, in the project which I showed, uh, how I have designed this.
No, my question is that in MBR we are using membrane, and again in MBBR we are again yeah, there also we are using carrier in the form of membrane. So both MBR and
No,
MBBR,
membrane is different. Membrane purpose is different, right? Here, carrier is not a membrane.
yeah, but in
Here,
MBR we are using a membrane,
yeah, we are using membrane. That's
and
what I have explained. No, see here.
yeah,
For sludge removal, we are not using a secondary clarifier. We are
yeah,
just using a membrane.
yeah. But in case of MBBR we are using membrane or not?
No, we are not. If you want, you can use membrane, or if you
Yeah,
want, you can use settling tank. It's up to you.
yeah, yeah. But both the cases we can tell that MBR is the advanced version of MBR, and similarly MBBR is also the advanced version of ASP. So whether we can tell MBBR is the advanced version of MBR or not? That's my question.
No. See here, all these things are separate things. Okay, what you are talking is like maybe you can tell for your understanding. You can tell that yeah, MBBR is advanced version of ASP. Okay, and
Yeah,
even MBR itself is advanced version of ASP only because in case of we are doing the same thing except the secondary clarifier we are putting a membrane to remove the solids. Are you getting my
yeah,
point? So
yes,
just
yes, ma'am.
understand the concept. That's like enough. You know
Yeah,
what is this and what is that. That is enough. If you want to like apply multiple things, you can just apply it based on your aptitude and based on your requirement. If it is required, then you can put a membrane for settling, or if it is not required, if you can just have like lot of space, if there is lot of space available for the secondary clarifier, then you can put a secondary clarifier. Okay,
okay,
if there is like less requirement, less space, but you are ready to spend money on energy. Okay, because obviously membrane processes will require energy, right? So in that case, then you can go for MBR. It all depends on like how you design. Here you just try to understand the concept. What is MBR? What is MBBR? That's enough.
okay.
Okay. Yeah. Okay. So that's all with the theory. So now we will go to the problems. Okay. So the first problem is okay. The first problem is I have some 8 to 10 problems. I think everything is like very simple. We can like complete it very quickly. That should not be a problem. An activated sludge plant treats 80 mld of wastewater with an influent COD of 400 mg per liter, and the reactor volume is 20,000 meter cube. Calculate the organic loading rate. Okay, and then if the plant is upgraded to MBR and the OLR is increased to 3 times, how much is the wastewater uh, the plant can handle with the new criteria, and assuming the same COD is present in the initial characterization of the wastewater treated. Okay, so first problem we can write the given is Q equal to 80 mld, and then we have fluent COD in equal to 400 mg per liter. Then we have volume of the reactor 20,000 meter cube. Okay, so given is this, to find this, first one is you have to find the organic loading rate. Second one is we have to find mu Q after updating to OLR equal to 3 times initial OLR. OLR initial. Okay, so let's go to the solution. Can someone tell me how to find the OLR, organic loading rate?
Ma'am, OLR in the sense means
Huh?
OLR in the sense means what I
Organic loading rate. OLR is organic loading rate. Okay. Does anyone know the formula for OLR? Okay, it's nothing but Q into COD divided by your volume. Okay, so what we are doing here is Q is nothing but initial Q, so 80
ATM.
into COD is 400 divided by volume is 20,000. Can you tell me the answer quickly?
1.6.
1.6. Oh yeah, it's 1.6. Yes, it's 1.6 kg per day per meter cube. And then for the second one, we have to find Q nu. And for second one, case 2, the OLR is OLR nu. Can you please mute?
Yeah, sure.
I'm sorry, I'm not able to concentrate properly. That's why. Okay, so 3 into 1.6, which is equal to So 3 into 1.6 equal to 4.8 kg per meter. Okay. So now we are given that the volume remains the same. The volume of the reactor is going to remain the same. Okay. And the COD is also going to remain the same. Only the OLR has changed. Okay. So new OLR is nothing but 4.8 is equal to Q nu into your COD remains the same and the tank volume remains the same. Okay. So if you substitute these things, you will get Q nu equal to 200 and 4.8, which is nothing but
240 mld.
40 ml. Okay. So the new tank capacity is like 240 ml. Okay. So now we will like move to the next problem. Okay. So the next problem is a sequential batch reactor SBR is operated at a HRT of 8 hours and treats 10 mld of wastewater. If the same reactor is modified into continuous flow reactor and is allowed to operate at a HRT of 4 hours, how much will be the new capacity? Okay, so there is SBR. Initially there is a SBR operating at HRT equal to 8 hours. Okay, and Q is equal to 10 mld. Okay, the same reactor is modified to a continuous flow reactor. Okay, and the HRT is 4 hours. Okay, we have to find what is the Q. Okay, uh, given both are of same volume. Okay, so we know what happens is uh, in case of same Q is equal to V by T, right? Q is equal to V by T, right? Here we have the same volume for both. Okay, time is given for both the things. However, Q for second one we have to like determine, right? So from the first one we can find what is the volume. Okay, so from SBR volume will be equal to SBR is equal to T into Q, which is nothing but 10 into 8 by 20, which is equal to 3.3 milliliters, which is nothing but 1 by, okay, so 0.33 into million liters. Okay, so now apply it to the second one, continuous flow reactor. Okay, so if we apply it, Q equal to 3 point divided by time is 4 hours, which is equal to 4 divided by 20. 3.3 divided by 4, 19.98 million liters. Okay, so approximately 20 million liters. Oh, sorry, MLD. This is MLD. Yes. So MLD. Okay. So the next problem we can go. Problem. Okay, so the next problem is an ASP is designed to treat wastewater with influent COD of 600 mg per liter. The effective volume is 15,000 meter cube. If the plant operates at the OLR of 0.4 kg of COD per meter cube per day, calculate the maximum wastewater flow. Okay, and then if the influent COD is suddenly increased to 900 mg per liter, keeping the volume constant, what is the new flow that can be treated at the same OLR? It is similar to the first problem. Can you please solve?
Now the question problem statement is not visible.
What?
Problem statement is not visible.
Not visible. Oh, is it visible now? Is it visible?
Yeah, ma'am.
Okay. I will give 4 minutes time. You can solve it. I will also solve it. Then we can discuss the answer. Is that okay? Is that okay for both of you?
Yeah, ma'am.
Okay.
Yeah, ma'am.
One second. Did you solve?
Yeah, ma'am.
Okay. What is the answer you're getting for the first one? The subdivision. I'm getting 10 mld. Kanu, what are you getting?
Yeah, ma'am. 10 ml.
10.
Okay. For second one, 6.67 mld.
Yeah, yeah, ma'am.
Okay. Fine. Now let's move to next problem. Okay. Okay. This is also similar to that. Like, I think you can itself solve. Similarly, I will give some time. I will also solve. Then we can discuss the answer. Okay. Is my screen visible?
No. Yeah.
Okay. Fine. Did you guys complete the problem or you need some more time? Okay, I'll wait until you guys complete the problem.
OLR is 2500 mg per liter. I think. I don't know.
2.5.
2.5. Then I have done some mistake in unit.
I'm getting 2.5. I'll just share this thing. See here, Q into COD in divided by volume. Okay, so 50 mLD into 500 mg per liter will give kg per day of COD. Okay, divided by volume is nothing but 10,000. So if we like substitute everything, then we will get 2.5 kg of COD per meter cube per day. That is the OLR. And then if the allowable OLR is uh, 0.5, okay, but what we are like having is 2.5, so it is overloaded. I'm sorry, it's not underloaded, it's overloaded. So the plant is overloaded. This is OLR allowable. More than the allowable OLR, the plant is loaded, so it is overloaded.
The OLR is 0.5 into COD. That means 0.5 to 250 mg per liter. No?
250 mg per liter. Um, what uh, what are you asking, Kanu? Can you please repeat it?
No, it's okay. Okay.
Can you please repeat it if you have some doubt?
No, actually, I was asking the capacity is 2.5 mg per liter.
Mg per liter.
No, kg per meter cube. No? Yeah, okay.
Maybe there might be some issue with the conversion, I guess, for you. Can you please check it like later?
Yeah, sure, no, sure.
Okay, thank you. Okay, so the next problem is a plant. Okay, so this is problem number 5. A plant treats 200 mLD at a OLR of 0.6 kg COD per meter cube per day. If the influent COD is 400 mg per liter, what is the required reactor volume? Okay, so uh, can you please solve this? Let me just share the screen. Yeah, you solve it, I'll also solve it, then we can like discuss the answer. Okay.
Ma'am, I think you have been stop your screens from your end. Please, can you do this?
Screen is visible, no? The question is visible, right?
Ma'am, it couldn't visible right now on screen, ma'am.
Oh. Kanu, is it not visible for you too?
No, I can see.
I'm also able to see. Wait, let me just stop presenting and then try to do it again. Is it visible now? Naidu, is it visible for you? Naidu, is it visible for you?
Yes, ma'am. Yes, ma'am. I'm by the click of a single line showing you.
Did you guys complete it?
You have
Yes, ma'am.
completed, but
Ma'am,
What
I
is the
got it.
volume?
It's I think too much big amount, big class volume.
153 meter cubes, right?
Ma'am, 133.3.
Can you please type the
One,
answer? Four point eight. How did you get 4.8, Naidu? Let me share my screen. Yeah, this is what, yeah, this answer I'm getting. Yes, this is the answer.
yeah, ma'am, I am also getting the same.
Okay. Okay, let's move to the next problem.
YouTube use volume, ma'am. I can able to say this. That's why.
Okay, okay. No problem. Okay, let's move to next problem then. Okay. A moving bed biofilm reactor MBBR of volume 600 meter cube is designed to fill with 50% filling ratio using biofilm carrier of density 950 meter cube kg per meter cube. Calculate the total mass of the carriers in tons. Okay, this is problem number 6. This problem I will solve because this is new type. So from next problem onwards, you can like solve it like similar to the previous one. Okay. So here given this is problem 6. Volume is equal to 600 meter cube. Okay. And then it has 50% filled with carrier. Okay. And the density of the carrier equal to 950 kg per meter cube. Okay. So now we have to calculate the mass of the carrier required. Okay. So this is the total volume of the reactor. In the total volume of reactor, 50% is filled with carrier. So implies volume occupied by the carrier equal to 600 into 50 by 100, which is nothing but 300 meter cube. Okay, so we have 300 meter cube of our carrier. So volume of carrier is 300 meter cube. However, the density of the carrier is equal to 950 meter cube kg per meter cube. Implies density equal to mass by volume equal to 950 kg per meter cube. So implies mass,
25 ton.
yep. Mass is equal to 950 into 300 is equal to, which is cancelled, 285 tons. Okay, so this is the answer. So similar to this, I have some 3 or 4 problems which I will share, and then we can solve and then discuss. Okay. This type of problem is asked in your assignment. Same question with different numbers. Okay. Okay. So the next question is similar to this. I will give some time. I will also solve. Then we can discuss the answer. Okay.
Two 45, ma'am. Ton.
Okay. I haven't solved it. Let me just solve. Just give me 2 minutes. Yes, I am also getting 245 tons. Okay. Naidu, is it okay for you? If we move to next problem.
Welcome.
Okay, next problem is also similar to this problem.
Four 60.8, ma'am.
Okay, just 2 minutes. 460.8 tons I'm getting. Yeah.
Yeah, ma'am.
Okay. So yeah, we will move to next problem. An MBR uses a carrier's. Okay, so this is a bit different problem. An MBR uses, but I think you will be able to answer. Anyway, like I will give some time. I will also solve, then we can like discuss. Okay. MBR uses carrier with specific surface area.
$75,000 square meter.
Give me 2 minutes, Kanu. I'll just solve it. I haven't completed it. $75,000.
Yeah, ma'am. 75,000.
75,000 meters square. Okay, so next question will be, yeah, and SBR treats, 1 second. Okay, and SBR treats 5,000 meter cube per day wastewater using two reactors operating alternatively, each of volume 2,000 meter cube. If each cycle consists of fill, react, settle, draw, and idle of like given time, calculate how many cycles a reactor can run per day. Verify if the plant can handle the flow. Okay. Let's solve this and then we will discuss the answer. Okay. One second. Hi Dinesh, how are you?
Fine, ma'am. How are you, ma'am?
I'm fine, I'm fine. We are solving this problem, okay? You also try to
Yes,
solve. I'll give some time. We all will solve, then we will discuss the answer. Is it okay?
yes, ma'am. Right. I have already read that problem, and how many cycles in this we have to add the hours only, no?
Yes, yes,
And this is only single basin, ma'am. Two reactors. Okay, there are two basins, two beans basins, no? So generally, ma'am, what I know is I'm just checking the background. What I know is generally when there are two basins, uh, one is under filling and aeration, and another is settling uh, and settling once it will be settling and another time it will be on decanting.
yeah,
So this cycle I don't know, it is like this only. I
yes,
worked
yes.
with two basin, one is in under filling aeration, another is on under either in settling or in decanting.
Yes, exactly. Yeah, that's how like that works practically. But for
Hmm.
our easy thing here, since see here, the time is not appropriate if we see. If we keep one thing in fill and react, other thing cannot be used for like settling and draw and idle. Like it won't match up with the time. So we can maybe now assume that both the things are working simultaneously. You're getting my
Okay, means
point?
both basin you are we are taking filling and react. But
Yeah, yeah, yeah,
okay,
yeah, yeah,
once
yeah. Similar cycle
so
timing. Yeah, but
that is
practically
okay, ma'am.
no.
But that is okay. Practically, it is not possible because see, the plant is to operate continuously. So if we are filling and aerating, if we are stopping, then the how where will the this water go?
Yeah,
At
exactly.
some
Yeah, that is the thing. But this is just theoretical question to understand
okay,
how many cycles.
okay,
That's it. So from
right, ma'am,
this,
right,
yeah.
right.
So yeah, I have seen the like plants also. I have seen like 4 or 5 tanks will be there, and
Yes, ma'am.
yeah, at the time like in one if react is happening, in other thing there will be settling, and one may be kept as like idle or something like that. Yeah, that is how it should work practically. And
Yes,
practically they give the cycling that between each phase time also like appropriately, like fill maybe for point 0.5, react maybe for like 2 hours, and then like so that we can like accommodate everything like appropriately. But this problem it's just like to check, uh, just for like theoretical understanding, so that's why.
right,
Okay.
right, ma'am. Right. I'll try. Yes. Thank you.
Did you all try it? Complete it? Okay, let me share the solution. Okay, so first, given is, this is the content that is given. Okay, that is Q equal to 5000 meter cube per day. We have two reactors with volume of 2000 meter cube. And the total cycle time will be 1 plus 4 plus 1 plus 0.5 plus 0.5, which is equal to 7 hours. For one reactor in one day, how many cycles it can handle? If we see, it's going to be 24 divided by 7. Okay, so one reactor can handle 3.42 cycles in a day, but we have two tanks. Okay, and then which is operating simultaneously. So into 2, if we put per day, it both the reactors together handles 6.84 cycles. Okay, so that is the answer for first subdivision. For second subdivision, verify if the plant can handle the flow. Okay, so for handling the flow, we need to know what is the total volume and what is the total treatment time, like HRT, like to treat the thing, right? So the HRT to treat is nothing but 7 by 24. That is 7 hours for one cycle, right? So 7 divided by 24. That is the HRT for treatment. HRT for treating one cycle. Okay. But in total, it can handle 6.84 cycles. So like maybe we can put as 6.84 into 6.84. Okay. And the total volume is nothing but we have 2000 plus 2000, so totally 4000. Okay, so 4000 divided by 4000 divided by 7 into 24 divided by 6.84. So which is nothing but approximately 2000.5. Okay, but the given flow is 5000 meter cube per day. So the plant cannot handle the flow. Okay.
Ma'am, I have one question, ma'am.
Yes.
Ma'am, this HRT, how you have calculated? Can you explain? I could not get it.
Which one?
HRT, you have calculated this 7 by this volume upon this one is the HRT generally volume upon time. What you have done is volume upon cycles per day. What you have done?
Oh, yeah. Okay. Got it. Yeah. So the first thing what I did was correct only, I guess. 7 by 24 is only right, I guess. Yeah. It's not the cycles. The cycles is not included. Yeah.
I'm not getting this. Could you please,
Yeah. I'm coming. See, HRT is nothing but how much, like, is the time required for treatment, right?
yes, ma'am.
HRT is how much is the time required for treatment. So here we are conducting in multiple cycles,
Yes, ma'am.
right? In multiple cycles we are conducting. Okay, so for one cycle, how much is the HRT?
One cycle, how much it is? Okay. The 7 by 24 is the, means almost 6.8 is the cycle, huh, ma'am? So
Yeah,
7 by
so
24, how
yeah,
you have done?
yeah, I'm coming for that only. See here, 7 by 24 is the HRT for one cycle, right?
Okay, means 6.8, it should be 6.8. 7, you have taken 7 or it is 7 by 24 only?
7 is this one, 7.
Okay, 7 hour is the total cycle time. Okay, okay.
Yeah, that's given in the question. Okay, so for one cycle, we need 7 hours. Okay,
Right.
and here we have totally 6.84 cycles.
Yes.
Okay, so that's why I have multiplied by 6.84.
Right.
Are you getting it?
Yes, I got it because 7 by 24 is a so much of hours is our residence time actually.
Yeah, for one cycle.
And for the total cycle, it will be multiplied. Yes,
Yeah,
got it.
got it?
Got it. And volume divided by this total residence time means the HRT is what? Volume divided by time is
Your total
what will
HRT.
okay total HRT. Right, ma'am.
Okay.
Is flow rate generally volume divided by flow rate is the HRT, na? Volume divided by flow rate.
Yes, but here we don't know what is the flow rate. Flow rate it can handle. Okay. See, some
Okay.
we are given some arbitrary flow rate in the question. Okay, we have to
Yes.
check if our tank is able to handle that much flow rate. Okay, our tank
Okay.
capacity is this much only. Okay, based on the cycle time and your volume, you have calculated what is your capacity of the tank. Okay, so that you are going to compare with the given flow.
So yes, here we want to calculate the flow rate. So we have divided with the time, which generally we calculate. Which is the
Exactly.
detention time. Which is the detention time. So here we
Exactly.
are dividing with the detention time so that we can calculate the flow rate which can be handled.
Yes.
I, yes, got your point, ma'am. Right.
Okay.
Hmm.
Okay, so that's it. Now we will go to the last problem of the session. Okay. So,
లాస్ట్ ప్రాబ్లం ఉంటుందన్నమాట చెప్పినాం కదా వాళ్ళు లేరంట మన వాళ్ళు ఇంటికి
okay.
పోతున్నారు
So an SPR of
ఆడు ఇంటికి
3000
పోయినాడు
meter cube um,
ఇంటికి
is used to treat
ఆడు మధ్యాహ్నం చెప్పినాడు కదా ఇంటికి పోతున్నాను
calculates amount
ఫోన్ మాట్లాడుతున్న నట్టుకోతుంది
I think Naidu should mute himself. No?
someone yeah, okay. Thank you. So the last problem is an SPR of 3000 meter cube is used to treat flow rate is given. If it operates 3 cycles per day, what is the HRT per cycle? Okay, so this is also very simple problem. So this is problem number 11. Okay, so given is volume equal to 3000 meter cube, Q equal to 6000 meter cube per day, and then you have number of cycles per day equal to 3. Okay, so what is the HRT per cycle? Okay, so now we have Q is equal to V by T. Okay, so this is like total HRT. Okay, so if you have to find total HRT, V by Q, which is nothing but 3000 divided by 6000, which is equal to half a day, nothing but 12 hours. 12 hours is the total HRT, okay? And then we have 3 cycles per day. And total HRT equal to 12 hours. Implies per day, the time HRT per cycle is equal to 12 divided by 3, which is nothing but 4 hours. Okay? Is it okay? See here, first we are calculating the total HRT. Okay? Total HRT we are getting by V by Q. Okay? It's nothing but 12 hours. Okay? You keep it aside. And then in a day there are 3 cycles only. Okay? So there are 3 cycles only, and totally it operates for 12 hours. So one cycle should be operating for 12 by 3, which is nothing but 4 hours. Okay, is it clear?
Yeah.
Okay. Okay then, so that's all for today's session. So thank you everyone who attended the session. I'll upload the video by today or tomorrow. Okay, thank you. Thanks for attending the session. Thank you everyone.
Thank you, ma'am.
Thank you.
Thank you, madam.
Thank you.